Welcome everybody to the last talk of our joint conference. My name is Kevin Govaerts, and I'm working for Ordina for a little more than over a year now as a Java developer. And my talk today is about monitoring a Spring Boot application with Prometheus and Grafana. I didn't really include an agenda slide, but I will be going over the basics of Prometheus, what it is, how it works, and how we can integrate Grafana and Prometheus with a Spring Boot application. So after the slides, I also prepared a demo so you can see that it's really easy to get started with monitoring your own applications. And for the people who have never heard about Prometheus, yeah, it's an open source monitoring tool, so free to use for everybody. And it's originally developed by SoundCloud. So start at the start. Well, what exactly is Prometheus? Prometheus actually got created to monitor very dynamic container environments, like, for example, a Kubernetes cluster or a Docker Swarm. But on the other hand, it is also possible to use it with traditional non-container infrastructure, like, for example, a bare-bones server with some applications deployed on it. And Prometheus has become the go-to choice over the last few years for many companies to monitor container and microservice infrastructure. So let me explain why Prometheus is so important now and what some use cases are. So modern DevOps is becoming more and more complex to manage manually, and therefore we need more automation. In such an environment, we usually have multiple servers running containerized applications, and there are hundreds of different processes running on that infrastructure, and they are all interconnected. So maintaining such an infrastructure and making sure it continues to run optimally without application downtimes is a pretty challenging job. So imagine having an infrastructure like this with different servers in different locations, physical or cloud, and you have no idea what's happening at hardware level or application level. Yeah, like errors or response latency. Hardware might get overloaded or disks might get full. And in such a complex infrastructure where there are thousand and one different things that can go wrong, then one of our services can crash, and then crash another service in turn, and so on and so forth. So when we have so many different moving parts, it is important that when a problem occurs, that we can find the cause quickly, or even better, that we can see it coming beforehand, and that we can fix it in advance. So if we would do it without a monitoring tool, then it would be really time consuming when we have to manually debug something like this. As an example, imagine that we are in a cluster environment and one server is running low on memory and has therefore stopped a running container responsible for synchronizing two databases running in different pods on a Kubernetes cluster. So by stopping the first container, these two database services are now also failing. And one of these databases is used for an authentication service, which now in turns also fails, of course, because the database is unavailable. Our application on the front end that uses this authentication service has now also given up, and we get an error message in the form of error authentication failed. So how do we know what went wrong? If there is no monitoring built in, then we don't have a schema like the one I show here. And then it becomes difficult and especially very time consuming to go find the error. Then we would have to debug all the way backwards to the container that got stopped, and we would lose a lot of time. First, we would ask ourselves, is the backend still running? Are there any exceptions? Is the authentication service still running? Why did it crash? And so all the way back to the failing service. So therefore, it would be much more interesting for us to have a tool that constantly monitors our environment. A tool that actually checks if all the services are up and running. And when something crashed, it would alert us immediately so we know exactly what happened. Or even better, a tool that sees problems coming before they become real problems. So in our example of the failing service, this tool would constantly check all the memory usages of our servers and send us a message when a certain server goes above a certain threshold, like, for example, 70% memory used for more than an hour, then it can start warning us. This way, we can act preemptively and solve the problems before they even happen. Memory usage is one example, but we can monitor, yeah, 1,001 things like disk space and network loads, etc. So, for example, there could be a service that fails and starts sending error logs messages in a loop, and this could overload the entire network. So then it's interesting that there is a tool that can quickly show you where the original problem is. And that is exactly what Prometheus does, automated monitoring and alerting as a part of a modern DevOps workflow. So how does Prometheus work under the hood? At the core, we have the Prometheus server, which provides the real monitoring work. And the Prometheus server actually consists of three parts. It has a time series database, which stores all the metrics data, like the current CPU usage or the amount of exceptions that occur in an application. And second, we have the data retrieval worker, who is responsible for pulling in all the metric data. It basically pulls all the data from, say, applications, virtual machines, services, etc. And then it also pushes all the data into the time series database. And then the third and final component, we have a web server or a server API, which accepts queries for the stored data from the database. We can then access the data through a front-end web UI of Prometheus itself, or with a more powerful visualization tool like Grafana. So this Prometheus server is monitoring a specific thing, and that thing we call a target. Such a target can be anything, like, for example, a full Linux or a Windows server, a standalone Apache server, single application, or as already mentioned, any service whatsoever. So each of these targets have a certain unit of monitoring. For a Linux server, it could be the current CPU status or memory and disk usage. For an application, it could be the exception count or request durations, anything really. The units that we want to monitor are called metrics, and it's these metrics that we store in our time series database. So for these metrics, Prometheus has a particular format, and that's actually a human readable text-based format. The example in the presentation is actually of a Spring Boot application where we make a Prometheus endpoint available via Spring Actuator. So for each metric, there are two types of attributes. First, we got a help type, which basically explains what the metric is. And yeah, this is also to improve the readability. So in the example is the recent CPU usage for the whole application. And then as a second attribute, we also have a type, which tells us what type of metric that it really is. Um, just a second. So first we have a help type, which basically explains what metric is, yeah, and that is to improve the readability. And so in the example is the recent CPU usage. And then the second attribute, we also have a type, and it tells us what type of metric that it really is. My presentation is acting strange. Um, so Prometheus basically gives us a multidimensional data model that allows us to create metrics with names and tags. So each type of application or service has its own standard metric, but we can also define our own metrics. First, we have some kind of counter that checks how many times something happened, like the number of requests service got or the number of exceptions it produced. Um, we have a metric that goes up and down, and that is represented by a gauge. Uh, for example, what is the value of the current CPU usage now, or what is the available disk space now, or how long is our application been up. And then finally, we have a histogram or a summary type, which represents how long something took or how big a request was. So now we have an interesting question. How does Prometheus collect this data from our infrastructure? Well, Prometheus scrapes this data from an HTTP endpoint, which is exposed by default on /metrics. So in order to properly collect this data, our target must provide this endpoint as well as provide the data in a format that Prometheus understands. So the text-based format we just saw on the last slide. Some servers already expose a slash metrics endpoint by default, so nothing needs to be changed about that to get the metrics in. But many services do not have a Prometheus endpoint. Um, so for this, they need to add a custom component. And this component we call an exporter. An exporter is actually a kind of a script or service which fetches metrics from our targets, translates them into the correct format that Prometheus understands, and then makes it available at the metrics endpoint where Prometheus can then scrape them. Prometheus has a list of different exporters on their websites, which we can freely use in our environments, such as for MySQL, Elasticsearch, Linux servers, build tools, cloud platforms, and much more. For example, for our Spring Boot demo application, I will be using the micrometer exporter. So as an example, if we wanted to monitor a Linux server, we would download the node exporter tar file from the Prometheus repo. We would untar and execute it on the server, after which it starts converting the metrics from the server to the correct Prometheus format. And then the metrics endpoint is made available. And then after that, we can tell Prometheus to scrape that endpoint. So these exporters are also available as Docker images, which makes them very useful in clusters. For example, if you want to monitor a MySQL container in Kubernetes, then we can start a sidecar container with the exporters in the same pod, which can connect to the MySQL container. So then it can start converting the MySQL metrics to the text-based Prometheus metrics, and then also make the endpoint available to get scraped. Still a word about the benefits of Prometheus. As I said, Prometheus pulls or scrapes data from endpoints, so that's a significant benefit. Many systems today use a push system, like AWS CloudWatch and New Relic, for example, which basically means that servers and applications themselves are responsible for pushing their data to the central platform for that monitoring tool. So if we are working with many microservices, then each service would be pushing their metrics to a central platform, which triggers or could trigger a high load on the network. And then we do have monitoring on our infrastructure, which is great by itself, but then monitoring can become our bottleneck due to the constant push requests from all of the services. And yet another drawback to a push system is that we have to install some sort of daemon service on each component that we want to monitor to push the metrics, whereas Prometheus just needs a scraping endpoint. And so by providing just an endpoint, different Prometheus servers or instances can collect this data. So we can start to create a high availability setup for Prometheus. Yet another advantage is that thanks to the pull system, Prometheus can easily detect if something is up and running. For example, if our target does not respond to our request or the endpoint is not available, then there is something wrong with our target that we want to monitor, and we can be 100% sure of that. Whereas with a push system, then it can have several causes other than just the service not being up if the data is not arriving on the central platform. For example, the network is having problems and packages get lost in transit or something else. So for certain jobs that only live a short time, we cannot provide an endpoint. And for that, Prometheus does have a push gateway available. So things like backups, batch jobs, serverless functions, and so on, these jobs often do not exist long enough to be scraped. And to monitor this, Prometheus also has a push gateway available so that these jobs can send their data directly to our database. The push gateway should only be used for this type of jobs, of course, for all the reasons that I just mentioned. So how does Prometheus now know when to scrape something, you may ask? This is all determined in a Prometheus.yaml file. And here we determine which targets Prometheus should scrape and at what interval. For this, Prometheus has a service discovery mechanism to find these endpoints. The example YAML file in the presentation is a standard example configuration. So in block one, we define the global configuration of Prometheus. where we say how often Prometheus should scrape its targets. And these we can also override for individual targets later. The second block is to define rules. And here we can define how and when certain alerts should be created and sent to our admins. Like, for example, that 70% memory usage for more than 1 hour. And then the third block is to define which services or resources Prometheus should monitor. Prometheus by itself also has a slash metric endpoint, so it can also monitor its own health. So in this YAML file, there are two jobs. The first one is called Prometheus, where he monitors his own health on the standard slash metrics endpoint. And the second job called Spring Actuator, where he monitors the Spring Boot application on a custom endpoint, which is then Actuator slash Prometheus. So a number of important points here. First, how does Prometheus now determine how these alerts should be triggered and who should receive these alerts? Prometheus has a special component, namely the alert manager, which is responsible for sending these alerts, which we have defined in the alert files through various channels which we can define ourselves. So for example, it could be via email, but it could just as easily be on a Slack channel or another notification client. So Prometheus looks at our alert files, and when a certain condition is triggered, it will send an alert through the defined channels. Another important point is data storage. Where does Prometheus store its data? He stores it on local storage, which can be a regular hard disk or an SSD. And there he will create the time series database. But it can also integrate with remote storage systems, so that's another option. And the data gets stored in a custom time series format, and that is also the reason why we cannot put it immediately into a relational database. So when we want to access this data, Prometheus allows us to send requests to our server API, and we can access this data through the Prometheus web UI or via PromQL requests. Um, or we can use powerful data visualization tools like Grafana, which under the hood also just uses PromQL to get our data out of the database. To illustrate what this query language looks like, I've put some examples here. It's a query language on itself, and apparently it has a fairly steep learning curve. Fortunately, we don't have to learn it by heart, since we have tools like Grafana who just do it for us under the hood. Um, yeah, this is Grafana. So instead of writing the queries ourselves, we can click together nice dashboards that use PromQL behind the scenes. Learning PromQL to create dashboards from zero in Grafana is fairly complex and also not super well documented. So that's why it's convenient that Grafana provides default layouts for hundreds of different applications. So you don't have to start clicking those together from zero. The example here is a pre-made dashboard from Micrometer that is actually built to map out the main components of a Java application. And on this, you can then add custom components to meet your own needs or monitor your own things that you want to monitor. So finally, a small summary with the different characteristics of Prometheus. It is designed to be reliable, even when other systems have problems, such that we can find and fix the problems. Each Prometheus server is standalone and self-contained, which means it does not depend on network storage or other services. It is designed to work when other parts of the infrastructure are broken. And we don't need an extensive setup to implement it, which is an advantage, of course. On the other hand, there are some disadvantages. The difficulty of scaling when we really have hundreds of servers and services, then we would have to set up then we would have to set up a number of Prometheus servers that would then scrape the different servers and then eventually aggregates all the data on one final Prometheus server. And though, yeah, Prometheus is easy to use and set up with one node, it can quickly become fairly complex when we set it up with different Prometheus servers. So yeah, that was a bit of the theory around Prometheus. And yeah, now I will show you how we can um, implement this with a Spring Boot application. So for the demo, I will be starting from a new project, and yeah, I will be using the Spring initializer for the name. I will give it a name, Prometheus join demo. The group will be BE Ordina, of course, and that is basically it. The only thing we need is Spring Web. Finish it up. The README we can close. So yeah, as you can see, just a normal Spring Boot application. And this is now the application that we would like to monitor. So to make our application ready to get monitored, the first thing we need to do is add some dependencies. Um, I will be copy pasting a little since it's Friday and everybody wants to go home in time. So the first dependency we need is Spring Boot starter actuator. Actuator, yeah, basically just exposes some HTTP endpoints where we can monitor some Java virtual machine metrics like health and dump. And this is what we basically need to expose also the Prometheus endpoint. But to expose it in a Prometheus format, we also need a second dependency, which is the micrometer dependency, what I talked about in the slides. Let's save this, important. And then to yeah, get the endpoint available, we need to add something in our application properties, which is basically telling actuator that it needs to include a Prometheus endpoint, show details, that it always has to show the details, and then we give a custom tag to our application. If we now start the application, we should get an endpoint available running on 8080 localhost actuator. So yeah, this is the endpoint of actuator, and the one we need is the Prometheus endpoint. So there should be our text-based file, which we get. So I don't know if it's visible for everybody. Make it a little bigger. So yeah, this just exposes some metrics, which we then want to import into Grafana. Um, to monitor our application, we need a Prometheus server instance, and for this I will be using Docker. Where is my command? So with this, I will start up a container, Prometheus. No, the first thing we need as well is another file, the Prometheus.yaml file, which is the configuration file. So Prometheus.yaml, we can put it wherever. It's like the one in the slide. And here we will define which endpoints Prometheus needs to scrape. So it's the same as in the slides. The first job that we define is Prometheus itself, where it can monitor its own health. Prometheus will run on port 1990. So yeah, by default, it will go to the /metrics endpoint. And then the second job is our Spring Boot application. And here we will define a custom path, which is actuator Prometheus, which you can also see here. And yeah, because we are running Prometheus in a container, we need to give our home network address of the local machine so we can find our instance. And this file we also need to put into Docker as well. So that's basically what I will be doing here. We expose port 1990, and I will be mounting this Prometheus.yaml file that I just created into the image. So if all goes well, our container should come up. Looks good. So if I now go to localhost 1990, then we get our Prometheus web UI. If we go to status targets, then we can see that both of our jobs, which we want to monitor, the Prometheus job and the Spring Boot app, we can see it here, and both are up. So yeah, everything is correct for the moment. In this web UI, you can also view some graphs for the data that we expose. So here I can search, for example, to some stuff about the Java virtual machine, classes loaded, execute in a graph, maybe 5 minutes, 1 minute. And yeah, so you can see that we loaded a little more than 7,500 classes already in Java virtual machine. Um, but yeah, this interface is not really what we want. So that's why we will be using Grafana um, to get a nicer view and a better dashboard. So to start Grafana, we will also do it with Docker. So it's a little more simple. It just starts up on port 3000. Docker PS, that also came up. Grafana we can reach on localhost 3000 then, if all goes well. The first time we log in, the username and the password is both admin, and then we need to change it. So yeah. Now we're in Grafana, and the first thing we need to do is to connect Prometheus to our Grafana interface. So under configuration and then data sources, we can add a data source. Yeah, we can add a lot of data sources, but the one we will be using is Prometheus, of course. We can give it a name. Prometheus is okay. We need to tell it where it can find the data, which is localhost 1990. The access, I change it to browser, and then we can save and test. And normally our data source is working, so that's already good. And then to get a dashboard, we could create it from scratch, and then we need to target everything that we really want. But we can use an already pre-made dashboard, which comes from Grafana itself. And the one I like to use is the 4701, which is from Micrometer. You can see that it's Micrometer. I just need to select the data source, the one we just configured. We import, and there you have it. I need to change the time a bit. Last 5 minutes, maybe. Yeah. So yeah, that's out of the box, the Micrometer dashboard, and it basically shows you all the Java virtual machine data and metrics that we got in this file, but now it's just in a nice dashboard. So pretty cool. Um, Maybe the last thing that I can show you. There is still time. Yeah, I guess so. We can also create our own custom metrics, and yeah, we do that in the code, of course. For this, I will be creating a new package, service package, where I will be creating a class, demo metrics. I will be copy pasting. Pum, pum. Close this as well. So yeah, the demo metrics class. Here we basically just want to define a counter metric and a gauge metric. We just inject the meter registry, which comes from the micrometer library. And on that meter registry, we can then define a demo counter and a demo gauge. And then we just need to call this method, get random metrics data. We just need to call this function like every second to get some random data in it. The gauge will be a random number between 0 and 100, and the counter will just increment indefinitely. To schedule this, we also need a schedule clause, demo metrics scheduler, scheduler. Pretty basic stuff. We inject the demo metrics clause, and then we can schedule to trigger custom metrics, and we just call the random metrics data like every 1,000 milliseconds, so every second. And to get random metrics data is the thing I just explained here. To enable the scheduling, I just need to do one more thing, which is enable scheduling, enable, and then we should be good to go. Rerun the application. It came up. I will refresh our Prometheus data. And normally now we should be able to find our custom metrics, demo counters. So yeah, here we have the demo counter, and for the moment it's on 7. If I refresh again, 21, 23. The other one we should also find, demo gauge, and that we can find here, 69, 7, 4. So yeah, now we can add this data as well to our Grafana instance. So to do this, we can just add a panel, add an empty panel, and then we can select the data source that we want. Well, not really the data source, but the metric that we want to select. So demo counter should be also here, demo counters. And then I will give it a name, demo counter. We just do apply. And now it's also on the dashboard. I will do the same thing for the gauge, put it next to the other one. Okay. For this, we will be targeting the gauge. I will give it the demo gauge name as well. And then we can select another type of visualization. There is a standard gauge one over here. So yeah, we will be using that. And then you can do a lot of custom things like adding thresholds so that it's visually more appealing or warning you. If I put 60 here, for example, in yellow, then we have like this nice gauge. Um, is it refreshing? So yeah, that's basically how you can set up your own dashboards using Prometheus and Grafana to monitor your Spring Boot application. It has a lot of uses, not the most sexy subject maybe, but yeah, I hope you learned something from it. And if you have any questions, yeah, you can ask them now in the chat or behind the desk. Let me know.